For the last example in this section, we're going to look at this contingency table, which relates the type of accident, either fatal or non-fatal, with whether or not a driver was wearing their seatbelt. And so part A asks us to find the probability of E, where E is the event that the driver wore a seatbelt. So here, I'll write that out in words. So seatbelt on. And so this is a simple probability or a marginal probability. And so I'm just going to look at the total number of people who are wearing their seatbelt. So 412,878 people out of the total number of people in my sample. So 577,006. Round your results to 4 decimal places. So when I do this, I get 0.7156. So about 72% of the people in this sample were wearing their seatbelts when they got into an accident. Part B asks us to find the probability of F, where F is the event the driver was in a non-fatal accident, so the probability of non-fatal. What I'm going to do is something very similar. It's still a marginal probability, so I just look at the total number of people in a non-fatal accident and divide it by the number of people in my sample. So 574,895 divided by the 577,006. And when I do this, I get 0.9963. Part C then asks us to find the probability that they happened at the same time, so that the driver was both wearing their seatbelt and were in a non-fatal accident. And so this is the one where I just look at the intersection of these two. So if I go back to my contingency table, I'm going to look at non-fatal and seatbelt on, and I'm going to look at this number. So this is the number of people that were both wearing their seatbelt and were in a non-fatal accident. And so 412,368, and it's still out of the total number of people in the sample, so 577,006. When I round this to 4 decimal places, I get 0.7147. And so if you look at the difference between A and C, then you can see that it's pretty close. So the number of people wearing their seatbelt and the number of people, or the percentage of people wearing their seatbelt and the percentage of people wearing their seatbelt who were not in a non-fatal accident are pretty much the same, right? So wear your seatbelt. Part D is asking us to find the probability that the driver was either wearing their seatbelt or was in a non-fatal accident. So seatbelt on or non-fatal. And so here I'm going to have to use the rule where I find the probability of seatbelt on first, subtract add the probability of non-fatal, and then subtract the probability of both. And so I found both of these pieces already. This was what I found in part A, this is what I found in part B, and this is what I found in part C. And so here you get 0.7156 plus 0.9963 minus 0.7147. After doing all of that, you get 0.9972. Okay, part E then says to find the probability of F complement given E complement. So let's write this out so it's a little bit easier to think about. F complement, if F is non-fatal, then the complement of that would be fatal. So find the probability that a person was in a fatal accident given E complement. If E is seatbelt on, then the complement of E would be seatbelt off. So here we're going to find the probability that a driver was in a fatal accident given that they were not wearing their seatbelts. And so here, my numerator is going to be the number of people who were not wearing their seatbelt and were in a fatal accident. And I'm going to divide it by, since this is based on the condition that they were not wearing their seatbelt, I'm only going to consider the total number of people who were not wearing their seatbelt, which is this 164,128. So I'll write that out in words real quick. So total number of people not wearing a seatbelt. And so here, the number of people who are not wearing a seatbelt and were in a fatal accident, that's going to be 1601. So 1601 divided by the total number of people not wearing their seatbelt, 164,128. And when you do this, when you round it to 4 decimal places, you should get 0.0098. Okay, so part F then is asking us if the events fatal accident and seatbelt on are independent or dependent. And so to figure this out, I can figure out if the probability of being in a fatal accident is equal to the probability of being in a fatal accident given that they were wearing their seatbelt, right? So this is the rule. If the probability of A is equal to the probability of A given B, then your two events are independent. So if this is true, then my events are independent. So let's find probability of fatal is going to be the total number of people in a fatal accident, so 2111, divided by the total number of people in my sample, 577,006. 577,006. Now the probability that somebody was in a fatal accident given that they had their seatbelt on, I'm going to look where the fatal and seatbelt on intersect. So 510. So that's my numerator here. And then I'm going to divide it by the total number of people who were wearing their seatbelt, which is that 412,878. And so here, if I reduce both of these to decimals, for the first one, you get, 0.0037. And for the second one, you get 0.0012. So since these two things are not equal, my events are going to be dependent.